Asteroid impact is a constant threat in our lives that one day an asteroid will strike a planet and in one instant the entire human species will be extinct. And it's not a fear that came up recently. Humans have always been fascinated by falling objects from the sky. And the realization that these objects could end up killing us led to the buildup of fear. And there have been various events in the past where these fears of ours have played out. Around 65 million years ago, an asteroid around 10 kilometers wide slammed into the Gulf of Mexico. This is probably the likely cause for the extinction of an entire species, dinosaurs. And it makes us wonder whether one day a very large asteroid, similar to the one that came 65 billion years ago, will strike Earth and we all will be gone. It's always there in fiction movies like Don't Look Up and Deep Impact, where this asteroid that's leading towards a planet is found very last moment. But at the end, there's always a hero that ends up saving the day. It's also shown in movies the consequences of an asteroid impact if it does occur, and the massive catastrophic events that follow this. But this is not just a fragment of friction. There's a small chance, a very, very small chance, that a large enough asteroid can hit our planet. We need to be ready for an event like this so we don't end up with the same fate as those fictional characters who are not able to stop that asteroid from slamming into Earth. Thankfully, there's no asteroid large enough that's on a direct path towards Earth, at least for now. But in the future, there may be an asteroid that's leading right towards our way, and we should have some sort of technology or way to avoid that. This is the reason why NASA recently tested out its DART, which stands for Double Asteroid Redirection Test, demonstrated the kinetic impactor technology. It's basically an asteroid is deflected, as in its orbit size is changed, following an impact from an impactor spacecraft. So it involves sending one or more large, high speed spacecraft to the path of an approaching near Earth object, like an asteroid. This impact could cause deflection of the asteroid, which ends up changing its trajectory, which steers it away from Earth's orbitable path, which avoids an impact and say. Great news that the DART mission was confirmed to be a success on 26th of September 2022. DART's target was a non-threatening asteroid. It was just chosen because it was an ideal candidate to be able to test out the technology and confirm its success in case they were needed in the future. The asteroid system on which this test was conducted is an eclipsing binary system, which consists of a large asteroid called Didymus, around which a smaller asteroid called Dimorphos orbits around. The impact was on Dimorphos, the smaller asteroid, and based on the change in the period time of the orbit, and we could calculate the impact the spacecraft had on the asteroid. This impact calculation is basically the amount of energy that was transferred to the asteroid that led to the deflection and then decreased the orbit. The reason why it's so important to know the energy was taken to deflect this asteroid by that certain amount is because in the future, there's an asteroid that's leaded towards Earth. We should be able to know how much energy we'll need to impact that asteroid with to ensure that Earth is not on its new trajectory. So prior to Darth's kinetic impact, the orbital period of Dimorphos around Didymus was 11 hours and 55 minutes. So DART spacecraft impacted the asteroid head on, instead of shortening the time it takes Dimorphos to orbit around Didymus. As I previously stated, the Didymus system is an eclipsing binary system. But what does this exactly mean? An eclipsing binary system is basically a system that consists of two celestial bodies which orbit in this particular way, which basically means that Dimorphos passes in front of and behind Didymus as it orbits the larger asteroid as seen from Earth. So we were able to calculate the change in orbital time period by using a light curve, which is a plot of the brightness of the system. The graph will have a straight line for maximum brightness. In this scenario, the maximum brightness will be when both the asteroids are reflecting off sunlight, which will particularly might be in when the asteroids are both like this. In this case, neither of them are blocking each other, and thus we can receive the light from both of them, and we get maximum reflection. There'll be dips in this curve as they end up eclipsing each other. If Dimorphos passes in front of Didymus, it will block off some light from Didymus, which causes a dip in the curve. As Dimorphos goes behind Didymus, Didymus will block off some light from Dimorphos, which called another dip in the graph. Now, looking at the number of times these light dips occur, we can tell how large of an orbit is there. And based on that, we can know the orbital period time. Earth-based telescopes can measure the regular variations in brightness of the system to determine the orbit of Dimorphos. The timing of the dart impact in September 2022 was chosen to be when the distance between Earth and Didymus is minimized to enable the highest quality telescope observations. What's so shocking is that after impact, the orbital period time was shortened to 11 hours 23 minutes. So shocking and surprising is because it was expected the orbital period time to only change by 1 minute 13 seconds. And the fact that we changed it by 32 minutes shows the success of the mission and the fact that it went beyond our expectations. It shows that it's far more fit for future missions where there may actually be a real threat and it'll be deflected by a large enough amount to have the confidence won't end up colliding with Earth. The change in Dimorphos's orbit by Dart's kinetic impact is designed to bring its orbit slightly closer to Didymus. The DART mission is a demonstration of a capability to respond to a potential asteroid impact threat, should one ever be discovered. And I'm sure all of you will feel a lot more lighter considering this problem that's been looming over us has finally a proposed solution that's been tested out. But our voyage is not over yet. We still have far more exploring to do. And on the next voyage, we'll be going near the James Webb Space Telescope. In our voyage, we'll be exploring that idea much further. Fasten your seatbelts because we are zooming out to the James Webb Space Telescope next. See you.